Now students, let us start with question number 6 of chapter limits and derivatives, exercise 12.3. Question number 6. Now let us see question number 6. Evaluate the following limits. Question is limit x tends to pi by 2 cos x upon pi by 2 minus x. So now students, if I directly put here pi by 2, then this is 0 by 0 form. So to solve or to find the limit, we use method of substitution. So we put x equal to either pi by 2 plus h or pi by 2 minus h. So I am putting x equal to pi by 2 plus h. As x tends to pi by 2, then h tends to 0. As x tends to pi by 2, h tends to 0. So our question becomes limit h tends to 0 cos of pi by 2 plus h upon pi by 2 minus of pi by 2 plus h, like this. So limit h tends to 0. Now cos 90 plus h, this is minus sin h, and when we solve it, we get pi by 2 minus of pi by 2 and minus h. So our question becomes limit h tends to 0 minus sin h upon minus h. So cancelling minus with minus, we get limit h tends to 0 sin h by h, and we know limit h tends to 0 sin h by h is 1. So students, this is the answer. So this is the sixth question, first part. Now let us do the second part. Sixth question, second part. Now question is limit x tends to pi by 2 cot x upon pi by 2 minus x. Again, if I put x equal to pi by 2 over here, then we get 0 upon 0 form. So students, to find the limit, we again put x equal to pi by 2 plus h. As x tends to pi by 2, h tends to 0. So our question becomes limit h tends to 0 cot pi by 2 plus h upon pi by 2 minus pi by 2 plus h. Now students, we know cot of 90 plus h, this is minus tangent h upon minus h. Now cancelling minus with minus sign, so we get limit h tends to 0 tangent h upon h, and now we know that limit h tends to 0 tangent h upon h equal to 1. So our answer is 1. So students, I hope this is clear to you. Now students, let us do the third part, sixth question, third part. Now the question is limit x tends to pi by 4 1 minus of tangent x upon x minus pi by 4. Now if I put the limit, then I get 0 upon 0 form. So to do this, again we put x equal to pi by 4 plus h, right? So as x tends to pi by 4, h tends to 0. So our question becomes limit h tends to 0 1 minus tangent of pi by 4 plus h upon pi by 4 plus h minus of pi by 4, like this. Now we get limit h tends to 0 1 minus. Now tangent of 45 plus h, we know the formula that tangent 45 plus theta equal to 1 plus tan h upon 1 minus of tangent h, and in the denominator we get h because pi by 4 get cancelled with pi by 4. Now take LCM. Limit h tends to 0. Now take LCM. 1 minus of tangent h. Now when we open the bracket, or let us do in the next step, first we take LCM like this. upon h 1 minus of tangent h, like this. Now open the bracket. So limit h tends to 0, we get minus of tangent h upon h 1 minus tangent h, like this. Now this is equal to limit h tends to 0, we get minus of 2 tangent h upon h 1 minus of tangent h, like this. Now putting the limit, now tangent h upon h, this is equal to 1, so we get minus 2 into 1 and 1 minus tan h. So putting the limit over here, 1 minus of tangent 0, tan 0 is 0, so our answer is minus 2. So students, the answer is minus 2. Now I hope students this is clear to you. Now the next question is limit x tends to pi by 6 root 3 sin x minus cos x upon x minus pi by 6. Now students, if I directly put pi by 6 over here, then we get 0 upon 0 form. Now students, to do this question, what we do, first I write coefficient of sin x in the numerator. Coefficient of sin x is root 3 and coefficient of cos x in the numerator is minus 1. So what we do the square of coefficient of sin x and coefficient of cos x. हमने क्या करना है, कोफिशिएंट ऑफ sin x का स्क्वायर करना है और कोफिशिएंट ऑफ cos x है उसका स्क्वायर करना है and then take the root. So we get 3 plus 1 under root, or we get root 4, and this is equal to 2. So we are getting 2. So what we do, we multiply and divide by 2 in the numerator. So we write like this, multiply and divide by 2, we get root 3 upon 2 sin x minus 1 upon 2 cos x upon x minus of pi by 6. Now after this, now root 3 upon 2, now in place of root 3 upon 2 we can write cos of pi by 6 into sin x. In place of 1 by 2 I can write sin of pi by 6, because sin 30 is 1 upon 2 and cos 30 is root 3 upon 2, cos x upon x minus of pi by 6. Now limit x tends to pi by 6 to, now this is the formula of sin a cos b minus cos a sin b. So this is equal to sin of a minus b. In place of sin a cos b minus cos a sin b, we can write sin of a minus b, x minus pi by 6. Now after this step, we put x equal to pi by 6 plus h. So as x tends to pi upon 6, h tends to 0. Right? Now our question becomes limit h tends to 0 to sin, replace x with pi by 6 plus h minus of pi by 6. Here also pi by 6 plus h minus of pi by 6. Now cancel these two. So our question becomes limit h tends to 0, 2 times of sin h upon h. So sin h upon h is 1, so we get 2 into 1. So our answer is 2. Now students, I hope this is clear to you. Now students, let us start with the fifth part of sixth question. Question is limit x tends to pi 1 minus sin x by 2 upon pi minus x. If I put pi over here, then we get 0 upon 0 form. So to do this question, we put x equal to pi plus h. As x tends to pi, h tends to 0. So limit h tends to 0 1 minus sine pi plus h upon 2 pi, and in place of x I can write pi plus h. So replace x with pi plus h. So we get now limit h tends to 0, 1 minus sine. Now separating, we get pi upon 2 plus h upon 2, and here we get minus h. So limit h tends to 0, 1, 90 plus h, it lies in second quadrant. So this is equal to minus of cos h by 2 upon minus h. Now students, we know the formula of 1 minus cos x. So in place of 1 minus cos h by 2, the formula is 2 sin square, और जो हमारा एंगल है उसका हम हाफ कर देते हैं, 2h by 4 upon minus h, like this. Right students, the formula of, because we know the formula of 1 minus cos 2x in trigonometry हमने पढ़ा है 1 minus cos 2x equals to 2 sin square x. So similarly 1 minus cos x, this is equal to 2 sin square x by 2, जो भी एंगल होता है उसका हाफ कर देते हैं. सो अगर हमारे पास 1 minus cos x by 2 है, सो x by 2 का हाफ होता है x by 4. So we write 2 sin square x by 4, like this. Now to find out this limit, students, there is a little correction here. We have whole square, so we write whole square, so we get minus h whole square, so this becomes h square. So here we have in the denominator h square. Now let us see that how to find out this limit. Now here we have h by 4 and sine square is there, so h by 4 का जो square है, the square of h by 4 is h square upon 16. The square of h by 4 is h square upon 16. तो हमारे पास h square तो है लेकिन 16 नहीं है, so multiply and divide by 16, like this. ठीक है, h by 4 है तो ऊपर स्क्वायर है हमारे पास, तो h by 4 का स्क्वायर होता है h square upon 16, so वो हमने अपॉन में बनाना है. Now we can write it like this. Now students, we can write it like this: 2 by 16 outside, 2 upon 16 outside, and we can write it like this: sine of h by 4 upon h by 4 its whole square. So this is equal to 1 by 8 into 1, so we are getting 1 upon 8. So students, this is the answer. So I hope this is clear to you students. Now let us start with this. Limit x tends to pi by 2, 1 plus cos 2x upon pi minus 2x whole square. Now if I put x equal to pi by 2, then we get 0 upon 0 form. So what we do, put x equal to pi by 2 plus h. So as x tends to pi by 2, h becomes 0. So we get limit h tends to 0, 1 plus cos 2 times of pi by 2 plus h, pi minus 2 times of pi by 2 plus h its whole square. Right? So solving it, limit h tends to 0, 1 plus cos. Now solving it, we get 2 into pi by 2 is pi, 2 into h is 2h, and here we get pi minus pi and minus 2h its whole square. Now what we get, now let us see. Limit h tends to 0, 1 plus cos pi plus 2h, it lies in third quadrant, so this is equal to 1 minus cos 2h, and cancel pi with pi, So here we get 4h square, right? So we get limit h tends to 0, 1 minus cos 2h. This is 2 sine square h upon 4h square. Now we can write it like this: 2 upon 4 limit h tends to 0 sine square h upon h square. So 1 by 2 limit h tends to 0 sine h by h whole square. So we get 1 upon 2 into 1. So this is equal to 1 by 2. So students, I hope this is clear to you. So answer is 1.2. Very simple question, students. So all these questions is to be done by using method of substitution. So students, I hope this is clear to you. Now in the next video we shall discuss about exponential and logarithmic limits in the next video. Thank you.